Hello and welcome to your channel AWS Cloud Bytes. I'm your host Bhavesh Kumar. Today we are going to start a new series covering AWS security and aspects around security by covering various services. Let's look into the services this episode is going to cover. We're going to cover services such as IAM, AWS Organizations, AWS IAM Identity Center, AWS Control Tower, AWS Resource Access Manager. We are going to have just slides for this particular presentation, but in the near future, we'll talk about or have a lab session around these. So stay tuned. Let's dig into IAM. IAM is short for Identity and Access Management. IAM enables you to have secure access to AWS resources. It allows you to manage permissions using policies and assign access with least privileges. Integration with AWS Service and multi-account setups. IAM supports multi-factor authentication, or MFA for short, in federated access. The purpose of IAM, the benefits are it allows you to have centralized access control. So you can manage your resources, all the AWS resources across accounts and services. It allows you to have a granular permission set, which means it allows you to have a fine-grained permission access using policies. IAM supports multi-factor authentication for enhanced security, so you have a secure authentication. IAM also allows you to have temporary access, so these temporary access credentials can be used through roles for services and federated users. IAM also dictates a principle of least privilege, where you should only give permissions that are required to minimize any kind of security risk. IAM also allows you to have audit and compliance. You can track the activities and meet compliance requirement using CloudTrail integration, as CloudTrail is enabled by default in all the AWS accounts. The last but not the least, scalability. IAM efficiently manages access for growing teams using groups. We will look at the groups and the roles. So it allows you to group and easily manage these users, applying roles to a group of users. Let's look into the four components that we discussed earlier. IAM can primarily be represented under these categories. There are additional things that come up under IAM, but we are going to start with these four categories. So you have IAM users, you have IAM groups, IAM roles, and IAM policies. IAM users are primarily representing people, or you can say applications, where you have a access key and password assigned to the resource. So you can have a user who can log in using the AWS console. Now, groups are basically for easy management of permissions. You group the users into a bucket, you can say. It's a category, like I want to say it's a developers group. So all the developers are assigned to this group. The policies are assigned, or a role is applied at a group level, so that if a user leaves tomorrow, if one person leaves an organization tomorrow, you don't have to remove that permission that was assigned to that user specifically, because if it is removed from the group, then the user will not have any access. Similarly, you have roles. Roles are used to get the temporary credentials for accessing AWS resources. These are ideal for applications, services, or federated access. Roles get their short-term credentials using the STS service. You can look at this picture over here. Policies. Policies are primarily JSON documents that define what permissions are allowed, what are denied. You have different kind of policies. You have identity-based policies, you have resource-based policies, you have service control policies, and then you have permission boundaries. But if you talk about the way the policies are managed, one is AWS managed, which means AWS is managing that policy for everyone. So any update in AWS policy, in AWS managed policy, will automatically be applied. If you are managing your own policy, which is called customer managed policy, then in that case, you have to upgrade or change based on how you want to apply the permission set. Similarly, there is an inline policy. This is something that is applied to a role, or given a resource, you can have an inline policy that can be applied to a single resource. Let's move on to AWS organizations. What is AWS organization? AWS Organization is a management service for centrally governing and managing multiple AWS accounts. You can have a managing account that is defined at the AWS organization root level, and then you can have all the member accounts. And these member accounts will be governed at a organization root level. We'll look at the hierarchy in the upcoming slide. But the key features are you can have account creation and management. So you can have multiple AWS accounts created under an org, or you can add an account by inviting an AWS account that is already existing. So you have that capability. The next one is about consolidated billing. The management account gets the bill for all the accounts. You can have billing done at a single account for all the accounts that are member of that particular AWS organization. That also gives you some of the savings if you are looking for compute-based saving, or if you have reserved instances, and those kind of saving plans can be applied at an org level. And if one account is not taking benefit of that, another AWS account can take benefit because the billing is done at an org level. So it's an aggregation of all the accounts usage. The third one is about service control policies. If you have like 10 member accounts in an org, and if you want to apply some guardrails for your organization, you don't have to go to each account and apply those guardrails. If you say nobody can use DynamoDB as a resource or as a service provided by AWS, so you can have a deny policy for that particular service, and it will not be allowed to be used by any of the accounts. Service control policy allows you to enforce those kind of permissions across all the member accounts. Now, each account can be further grouped into sub-units, like you have 3 accounts or 4 accounts, and out of those 4 accounts, 2 AWS accounts are from finance, and rest of the 2 accounts are from the sales. You can have a finance OU and you can have a sales OU. Given the least privilege principle, we should be applying a different control on the finance OU, or the organizational unit, which is allowing it to just cater to whatever the requirements of finance is, while the sales can have a different set of rules or the policies allowed. A multi-account structure, or you can say a strategy that enhances security, isolates workloads, and improves operational efficiency. By structuring AWS accounts logically, organizations can better manage security, costs, and compliance while maintaining agility in cloud operations. What are the benefits of having AWS organizations? It simplifies account management and billing, centralized security and compliance. It facilitates multi-account strategy for better resource segregation. What are the use cases? If you need a centralized security policies for enterprise environments, if you need isolating development, testing, and production environments, or if you need multi-account governance strategy, you should use AWS organizations. This is a picture of AWS organization. You can see there is an organization root, and organization root has a management account. This is where you create policies, and you can apply it to root, apply it to OUs, or even at an account level. So the policies are sitting here. It can be directly applied at the root level. It can be applied at an OU level, or it can be applied at a member account level. And if you see, there are groups. So OU is just a grouping of accounts. So you can see 1 account, 2 account, they fall under this particular OU. And there are 2 other accounts, they fall under this particular OU. OU is just a container or subcontainer of an organization where you have a set of member accounts. In this picture, I was wrong. Basically, this is another OU under an OU. So this is just grouping of a section of an account. You can have this can be finance, this can be sales, and then in finance, you can have another subdivision of finance, multiple OUs over here. So that's how it is organized. You can apply all these policies at various levels. You can even apply at a sub or a nested level. Okay, let's move on to the AWS IAM Identity Center. So what is AWS IAM Identity Center? Well, it is a centralized service for managing a single sign-on access to AWS accounts and applications. It integrates seamlessly with AWS organizations. The key features of AWS IAM Identity Center are SSO access for AWS accounts and third-party applications, fine-grained permissions with reusable permission sets, integration with external identity providers such as Okta, Microsoft AD, and multi-factor authentication or MFA for enhanced security. The benefits of using AWS IAM Identity Center are security. We have a centralized control on security and compliance with MFA, which reduces risk. And then it simplifies the access management. Efficiency, it streamlines the login and permission management. And scalability, handling growing organization in multiple accounts. We'll have a look at the picture of AWS IAM Identity Center in the subsequent slides. Now, how does it work with other services? What kind of integrations are available? It works with AWS services like CloudTrail and CloudWatch for monitoring. And it also supports SAML 2.0 and OpenID Connect identity providers. The use cases to use AWS IAM Identity Center are: if you need a centralized access for multi-account environments, if you need an enterprise SSO for third-party applications, and if your requirement is to have a security compliance with MFA or multi-factor authentication, and if you need to give granular permissions, so for that you have AWS IAM Identity Center. Now this picture that is coming up on your screen, it's a dashboard. So once you enable AWS Identity Center and you go to this particular service, you will find that there is a access portal and there is a issuer URL. This access portal will be enabled once you have multiple accounts that are created. And if you enable the AWS Identity Center, you can see there are users and groups. And these are different users and groups than the users that you have in AWS IAM. You also have permission sets and AWS accounts. If I go to one of the login, if I click on, suppose I click on this particular URL, which is grayed out over here. This is an SSO URL. You can always edit this URL to a specific DNS name that is allowed by AWS. Once you log into this, you will see what all accounts you have access to. This is your landing page after the SSO login. You'll see the accounts. This is one of my accounts that I added to the SSO. But you can also see what applications are enabled or allowed by your SSO login. And if you have n number of accounts, AWS accounts, you will see all these accounts. You can open this caret button, which is going to expand this. And then we'll see a couple of links. One link will be to log into the AWS console. The other link will be to get the access token for programmatic access. You can have this SSO login at an enterprise level so that you can access to whatever AWS accounts your organization is enabling you to log in without entering your password for multiple accounts multiple times. Let's look into the AWS Control Tower. Now, what is an AWS Control Tower? It's a service for automating the setup and governance of secure multi-account AWS environments. It is built on top of AWS organizations to simplify account management. The key features are you have a landing zone, baseline environment for new account with secure configuration. You have guardrails, which is like preventive or detective rules to maintain compliance. You have account factory, which simplifies the provisioning of new accounts. In case you want to add new accounts, there will be some set of steps or some set of things that are already provisioned. A dashboard gives you a centralized view for governance and activity monitoring. The benefits of using AWS Control Tower are it simplifies multi-account setup and management. This is more about setup and management. It ensures consistency, compliance, and security at scale. The use cases where you are going to use AWS Control Tower are enterprise account management, where you have centralized governance for large-scale organizations. Then you have regulatory compliance, which requires enforcement of security and operational best practices. Quick onboarding, streamlined account setup for new teams or new projects. This is a picture or an image of Control Tower in action. AWS Control Towers are categorized according to their behavior and their guidance. There are three primary types of control behaviors. Preventive controls, which is number one. Then you have detective controls, then proactive controls. Preventive controls are designed to prevent actions from occurring. These are implemented with service control policies or resource control policies in AWS organizations. And the status of a preventive control is either enforced or not enabled. Preventive controls are supported in all AWS regions. Detective controls, this one, number 2, they are designed to detect specific events when they occur and log the action in AWS Cloud Trails. These are implemented with AWS config rules. The status of a defective control is either clear, in violation, or not enabled. Defective controls apply only on those AWS regions supported by AWS Control Tower. Now, the third one, proactive controls. Proactive controls scan resources that would be provisioned by AWS CloudFormation and check whether they are compliant with your company policies and objectives. Resources that are not compliant will be errored out. Basically, it will not be provisioned. These are implemented with AWS CloudFormation hooks. The status of proactive control is pass, fail, or skip. There is additional thing that is not shown on this picture, which is about control guidance. Control guidance refers to the recommended practice for how to apply each control to your OUs. AWS Control Tower provides 3 categories of guidance. One is mandatory, strongly recommended, and elective. The guidance of a control is independent of its behavior. Okay, let's talk about AWS Resource Access Manager. What is a AWS Resource Access Manager? It's a service that allows you to share AWS resources across accounts or within AWS organizations. It enables efficient resource utilization without duplicating resources. Key features: AWS Resource Access Manager share supported resources such as VPCs, transit gateways, license manager configurations, etc. It also shares these resources securely across accounts. There is a seamless integration with AWS organizations for cross-account sharing. Granular sharing options to control access permissions are also available. What are the use cases when you will require Resource Access Manager? If you want to have a centralized networking, like you want to have a single transit gateway for allowing the traffic to go or overall networking to flow from. If you want to have some cost efficiency, like you don't want to duplicate the same kind of resource in multiple accounts. Multi-account access provides teams or projects in separate accounts to access shared resources. The supported resources are VPC subnets, so you can have one single VPC and you can share subnets out of those VPC with multiple accounts. Similarly, you have transit gateways, Route 53 resolver rules, and many more. There's a picture of Resource Access Manager. So you can see that in AWS RAM, your account is the sharer. So this is the sharer account on the left. And then if you want to use a RAM, so this is RAM, and this is what, there is a new transit gateway that you have. And then you want that all the VPCs, when the data is flowing through, it should go through some network appliance. You can have the network done in this way that all the data flows through the network appliance. In this case, there is a third-party account where you have 2 VPCs. They are connected to the transit gateway, and you may have a rule where all the data flows through, like this inspection VPC is working as an interceptor in the middle. So once the data goes out, it goes out by going through the inspection. Once the data comes back or there is an inflow, it goes through the inspection to whatever the internal VPCs are. Hope this was helpful. And this is the end of this particular episode. We are going to have additional videos around AWS security, so please stay tuned. If you like the video, please like, share, subscribe, and press the notification bell icon for future updates. This is your host, Bhavesh Kumar, sign off. Thank you.